out this evening and speaking with us. So Bonafide was an idea a couple of years ago because we had to ask ourselves a question. When you look at all the different technologies, security technologies that exist to date, why are there still records being stolen? We'll get into some of the numbers and some of the facts that are happening in the world today, and specifically also in Ireland. That when you look at the amount of effort in the industry focused on trying to protect data, they seem to be doing a job of more guarding it, but the data keeps getting out. And you have to ask that question. And we did so on ourselves, and we had to say, okay, so how can we stop this? It wasn't really trying to build a better mousetrap. It was really looking into the real cause as to how these personal records of customers and individuals are getting into the hands of the cyber criminals. And what we found was it really had to do with where the data resides and how do you get to it. Modern day, applications are backed by a database. Most folks know that. In the enterprise, they definitely know it. When you get online, you do retail, maybe you get on Amazon and you're searching for something you want to buy, you're literally searching a database. If it's health services and you're looking at your records, x-rays, test results, that's all sits in a database. So when the databases are cracked open, that's when the information is taken out. So we basically at Bonafide, we said, how can we fix this? Some of the things that I've mentioned in other talks is most people don't know that the ability to encrypt data, that technology was invented decades ago. It progressed, from the 50s, but literally in the last 19 to 20 years, there's been no update to encryption technology. AES 256 is the best we have. If it's implemented, it protects pretty well, but that's really one of the biggest challenges. So for Bonafide, it was, could we protect the data within a database? And that's where we got started. And then it was, how easy is it for you to implement it without making any changes to your infrastructure, networks, protocols, security protocols, the databases themselves, the applications. And that was our approach, right? We wanted to make this as transparent as humanly possible and work on any kind of device. That's the sort of generally where Bonafide came from, and that's where we're focused today. So for the so
keep
for the
going.
group, so for the group, feel free to ask questions. We want to try and have this as a, sort of a casual conversation, about what it takes. I got a couple of slides to show. Did not want to make this, sort of a formal presentation, but I can jump right into it. And like I said, raise your hand, interrupt, ask the questions. But I think I'm going to share the screen here real quick. And let's look at some stuff. So let's look at the big picture. I mentioned that it's about protecting databases. Well, here's why. If you look at the various industries at the top of this slide, you'll see that it reaches from health services, to typical customer management systems or enterprise resource systems, telecom, shopping, and nowadays. More than half, about 48% of enterprises keep their data in the cloud. In the center is, quite frankly, all of these resources that are available, not just the storage, but the databases that are put up by the likes of Azure and Amazon, and AWS, and Google. These are all various different types of databases that are holding the information from these various different sectors in the marketplace. The data itself sits there and waits until the customers down at the bottom begin to use that data and go to do searches and do queries or interoperate with a data app to pull that information down for the information that they need. The problem is, so are the cyber criminals. They go and they target these environments, and they go and they get the data. They get the data out of those databases themselves through various different mechanisms. They could either be direct attacks. They log in for some of these systems can be phished, and then the data starts pulling out. The challenges are really big worldwide, and also in Ireland itself. The numbers are staggering. Worldwide, essentially there's about 6 million records that are stolen each day. 6 million. That equates to about 39 cyber attacks. A cyber attack occurring every 39 seconds. And I can't believe these numbers, as I start to see them updated in 2020. It's gotten so bad that up through September of this year, we don't have the Q4 numbers yet, but up to September this year, about 36 million records were stolen through a data breach this year alone. Now, it's really bad because if you look at the previous 7 years, from about 2013 to 2019, when the records were being sort of accounted for and tracked, there was about 25 million records that were stolen in that. 25 billion records that were stolen in that time frame. So just this year alone, 36 billion records. So more than 50% more than the 7 years combined previously. This is how much it's out of control. In Ireland alone, we did some work so you guys can understand what's happening in your area. In Ireland alone, about 6,000 data security breaches were reported in 2019 to the Data Protection Council. Guys, that's about 70% increase from 2018. If I go back to 2017, when all this first started tracking to occur, it was a 70% increase from then. Unfortunately, the Republic ranks about second across Europe in the number of notifications in stolen records per capita. And so the reason why we think it's targeted so much in Ireland is that the top 3 sectors that are hit hard by data breaches is health services, retail, and finance. And Ireland is well known, to attract some very popular and big businesses, for the benefits of operating, within Ireland itself. But that means that it's now being heavily targeted by the cyber criminals, whether it be a national driven group or organization, or privateers. And this is sort of the big picture that I want to sort of point out. You may be asking yourself, look, you've got the horsepower of Amazon and Microsoft and Google. How are they not able to stop the data from being stolen? Well, I'll take you to the second of only 3 slides that I want to speak to. It's very basic. The ability to protect data in a database comes in a couple of forms. And some of you may know this already if you've deployed it. Some of you may not. And you'll hear all kinds of technology and terminologies being used. So the diagram at the top is very easy to understand. And the result is this: with all this level of protection, there is a false sense of security here because the data is being stolen anyways. Look, if we've had nearly 60 billion records stolen to date, there's got to be a reason for it. Well, here it is. On the left-hand side is your mobile users, your desktop users, your nomadic users that are actually trying to connect into the web and conduct some type of business or entertainment. They'll typically use something like SSL or TLS to do that connection, right? That's that little lock that one usually sees on the screen that says, look, okay, your connection to the web server is protected. The problem is that it's only the man in the middle. If someone intercept those bits, could they take your data? So that means that from the web server, where you log into a website and use the app, the data is protected in flight. When it lands on the machine itself, it's in the clear. Before it goes in flight, it's in the clear, meaning that it's not encrypted, that anybody can read it, anybody can see it. So SSL and TLS does a good job of that, but that's not where the data is stolen. We have to go back to the right. So these web servers that are running that you connect to, they interface with the database itself. That's the DBMS block in the middle there. It has a couple of technologies available to it. One is called CLE, or column level encryption. You can literally encrypt data in a single column in a database, in a set of tables. You have millions of rows and you got a number of columns. The problem with CLE is that it's got a big impact on performance. You could lose anywhere between 15 to 30% performance of your database while you're doing queries. So it's typically not used, but if it is, it's maybe for 1 or 2 columns. So then the rest of the data is left in the clear. And then the last thing is something called TDE, or transparent data encryption. This is when the data is written to the storage, and that is you go all the way to the right. I just got to tell you that when you hear terms of data at rest and that it's protected, with a key, that's great. Only when the actual physical storage is stolen. I got to tell you, I've, in the last 10, 15 years, with data centers and co-locations and the cloud, I haven't really heard of a single theft of someone stealing, a centralized NAS or SAN storage system with the data on it. So yes, it does protect it, and it is required, by many governments to do that types of protection. So then it says, look, if each one of them are for these various different types of penetration, where do they get the data? All they have to do on the left-hand side is pretend to be an end user, and they can actually just query the database and stream all of the data out. We'll stop there and see if there's any questions. Otherwise, we'll start to talk about the ways we can start protecting it.
I have a quick question for you, Todd. So given you guys, okay, you're going to basically encrypt the data on the database, and that data is encrypted with keys. So from a performance, what can it, like, is it going to impact the performance on the database by running queries? Is it going to impact the performance of the network, or is it going to impact any application itself?
I'll actually answer the first part of the question. I'll let Todd answer the second. Let's sort of speak a little bit about our technology and what we do. And let's stick with this drawing that's here. The idea is this: what we want to do is we want to protect the actual data that's put into the database. So now, when you take a look at this drawing, it says, look, if I'm writing data into the database, I'm going to encrypt it, send it through to the database itself. That means it's sitting in the database encrypted. So if somebody were to steal it, whether in flight, in use, or all the way to the right-hand side at rest, all they're getting is encrypted data. Many people will ask, how is this possible? Here's the simplest analogy I can give. A database doesn't care what language you use. You can put data into a database in German, English, French, Italian. What you have to do is you have to make sure that if you're requesting data from a database in a particular language, you have to ask it for that same piece of data in the same language. If not, I have to have some way of interpreting it. This is the idea as to why we're able to protect data and not impact the entire infrastructure itself. Because look, if you build a database in German, it's not going to run slower, because you've decided to do it in English or in Italian. It doesn't matter. It just fits at the end of the day. The next question is, how come no one's done it before? The approach to getting it done, it has. This is the idea behind CLE, and it is a big performance impact. Columnar level encryption is very expensive to use because the database has to be the entity to do the encryption and decryption. What we've done is we've moved it all the way to the left-hand side to the endpoint devices. Now all we have to worry about is, how do they get the keys? So now that everything to the right is not impacted by performance, because it's still just operating on bits themselves, but it's not worried about decoding encrypting and decrypting data. It's just worried about choosing the data you're asking for. So that means that your endpoint devices are the ones that have to be responsible for this. So we've created a couple of solutions. One is an 800-bit encryption algorithm that runs on an endpoint device. Very extremely lightweight, very advanced next generation technology. The core of the encryption algorithm was developed over 20 years ago, but we've applied it to an 800-bit algorithm. We can use things like AES 256 as well, but it does require endpoint devices to have enough capability to support that. We can work all the way down to the smallest, lightest weight endpoint computing device. So then what we do is we make requests of encrypted information so that the database knows how to go look that up. We've tested it across many different applications and deployments. We don't care whether it's a third-party app. So you may be familiar with American companies like ServiceNow, Facebook, Salesforce.com. All of these are back-ended by a database. So what we do is we encrypt the data before they get it. And we do it on the left-hand side and pass it through. Like that web app, what could be a front end for ServiceNow. So now if you run a business and you leverage ServiceNow for their ability to support your customers, you don't have to worry about what endpoint device that they're running. You don't have to worry about the network domain or the security domain they're running. Everyone has to get authentication on the endpoint device to get the key so that you can unlock the data at the endpoint device, and only the data that's been requested, not all of it, because we operate at a very fine granularity. If you have 10 million fields in a database, we can use 10 million keys. If you want to make this stuff searchable and usable by the database, you'll probably encrypt an entire column with the same, with a single key. But if you want to protect user information, let's say something similar to a social security number that identifies you, by the government, you probably want to use a key specifically for that. We don't care if it's data, we don't care if it's pictures, we don't care if it's audio, we don't care if it's structured or unstructured. It's just a matter of trying to figure out how to get the key and the data into one place. So Bonafeyed technology is really worried about creating keys and serving keys, and then doing the encryption decryption at the endpoint device. Does that generally answer your question, Ken?
Yeah. It certainly
Well,
does.
I'll toss a little more in on performance.
Yeah.
So looking at the same diagram there, you look at the DBMS, if you've done any kind of CLE stuff, what happens is that normally they'll recommend, if you want to use it, do one column, maybe do 2 columns, and then don't do any more, because you're putting all that strain on the database engine back there. It's trying to encrypt, decrypt everything. It's doing it all. And other things you may find out there for doing data protection, they'll have these appliances that you install, and you keep scaling those out as you get more users, as you get more data. And so there's always this thought process of, let's encrypt only what we absolutely have to encrypt, and just hope that the other information is invaluable. We go the other direction, which says just encrypt everything. And by moving all of that crypto to the client device, what happens is that the data is protected all the way through that diagram, all the way to the server. It stays encrypted in the database server and all the way back. So all the other exploits that may come out, you'll read about, where people break into firewalls, they break into intrusion detection systems, they break into your database, they break in, whatever they break into, they're only ever going to get encrypted data. Even when it goes in and out of SSL, they're still only getting data that's encrypted. And so by pushing all that processing back to the client device, a client device is just going to encrypt the data they need to use right then. It comes into the device, it's still encrypted. When you actually go to display it, then you'll go ahead and decrypt it or act on it if you want to do some computation, and then throw it on the screen. So that processing is done on your device. And so you don't have to worry about decrypting huge blocks of data just to search the database. That happens automatically. You just decrypt what you want. So you can actually scale very easily, because you're going to take another 100 milliseconds maybe to decrypt a page of data that's on your iPhone or on your laptop. iPhone's faster than laptops, but so on your iPhone a little faster, but 100 milliseconds, you don't even feel it. You don't notice it at all. The rest of the transmission is the same as it was before. The database access is the same as it was before. It's just now all of that data is protected, and you don't notice any difference in performance.
Yeah, let me go to a new diagram. This is on the right-hand side. This diagram is really meant to show kind of what a sort of a typical deployment not would look like for Bonafeyed, but what would look like for any kind of cloud-based application that's backended by a database. For us, we don't really care what database it is. It works with all of it. It's neutral for all. It doesn't matter to us whether it's a SQL style of database or if it's a NoSQL style or NoSQL style of database. They're all the same to us because they're just reading and writing data, whether encrypted or not. But the types of end users are more important. In the sort of left of the diagram, we put some DevOps, DBA style of user, and then we have 3 different types of end clients, whether it be a legacy device that can't get updated with any particular software, a smart client that when a customer were to deploy with the technology, we have a software development kit, just adding 2 lines of code to an existing web app or a sort of a local application that's deployed on a client device, whether it be a smartphone or a laptop, and then it just automatically supports it. Or if it's third party, or if it's an old app running through a web browser, we have mechanisms that take seconds to deploy on each one of those systems, such that when you do a request for information, 2 things happen. on the left-hand side, all those clients basically put in, a request to a web server, a RESTful style of server that's in the lower middle of the diagram. And then up at the top is where the magic happens. We have our CSA, which is our cybersecurity security arbiter. And what it is it runs in the cloud, and it has all the keys for all the data that's being protected. And you'll notice that green path is where keys are delivered to the various types of end clients. And that's where the data is unlocked. In the case of a legacy client, we have a proxy box we call DSX, which essentially does the requests and delivers the data to the client that does not have the ability to, to use technology because it's too old. If it is, then it goes directly to that endpoint client device. This is how the system works. And on the back end, it could be any database. It can even be any kind of search engine connected to a database, because there's third-party search engines that are connected to a database. It all works perfectly fine, and it doesn't matter whether it's a special type of query for information. You can do ranged exact matches, starts with, contains. It can be pictures. It could be unstructured data, like comment section. All that stuff is searchable. Normally, this is not possible, and all of this isn't able to be done unless it's a proprietary solution that someone would have to deploy in their infrastructure to get it done. We're agnostic to all of the software components, networking components in security. We do recommend everyone continue with the same perimeter-based security that they may have deployed already. We hook into the authentication layers that already exist within an infrastructure, because some people will say, geez, I can't manage all those keys. No, we don't ask you to manage those keys. We just basically ask you to tell us, who do you want to have access to the data? Well, you do that today already. You use access control lists, ACLs, LDAPs. You use systems active directories to identify what files, what entries in a database. Those are the same things you use. Just use email addresses. We use that to identify those folks on the endpoint devices so we can figure out who gets the keys. We say, think of trillions of keys. Okay, here's why we say it. Let's say you have a database. It's got 10 million rows in it. It's got 40 or 50 columns. And let's say you've got 10 of those. So now you have 800 columns of data, and you've got 100 million rows of information you're trying to protect. You can put a key for every row, in a particular column. You can put a key for every column. And this is where you start to get, into millions of keys right away. If someone were to steal an endpoint device, happens often in health services. You'll have someone who has records or access to records, on a laptop, and they get stolen. It has happened in Ireland. As a matter of fact, you guys have open cases specifically on this where millions of records got stolen. Very recently, actually, in the last few months. We do limit of liability, limit of loss. That endpoint device may have a handful of keys on it, maybe hundreds of keys. When data comes from the database encrypted, it will land on that endpoint device encrypted and stays encrypted. The only time it's decrypted is when it's displayed. Otherwise, it stays encrypted. So when someone steals that device, even if it's wide open, they will only steal encrypted information, and they have to figure out what keys go where. And then they have to ask the CSA up at the top where those keys are at. Now, this is really important, because this is how we stop the cyber criminals in their tracks. So if someone were to go and get access to the database and they steal every entry in the database, all they've stolen is encrypted data, granularly encrypted data. They still got to get the keys. So when it comes to a zero-day attack, a laptop got stolen, credentials got phished, we monitor who gets keys, and there's all kinds of controls that the DevOps folks in IT can put limits on. They can say how many keys you can get per minute, per hour. We can say how many keys you can have total. Normally, if it's a user, they don't have access to 100% of all the information that's sitting in your database, some fraction of it. So this is where you have limits of liability. I mean, let's talk dollars. Some people, think that they have a small business. Let's say that, on the folks that are listening to the podcast, they have a database with 100,000 users in it. Not a lot, right? This is in a comparison to the millions and billions we've talked about already. The average cost of a small business with a database of 100,000 users with PII information into it is essentially $3.6 million US dollars. That's the penalties that are being paid when you violate GDPR on average worldwide. Same thing happens within Ireland itself. We also looked, if a breach happens to that same business, it could be a loss of about $1.5 million on average. It gets worse as it gets bigger. So if there's customers that are on the call right now, and they have, let's say, 1 to 10 million records, the average cost of that breach is $50 million. So all of a sudden now, it gets to be, 10 to 20 times higher in cost. So it's exponentially more the more records you lose. If it's a large company, let's say with records over 50 million that gets lost in a breach, it's about, on average, okay, $400 million in cost and penalties. So you have to cover the customers that lost their data and the penalties that get paid, within the EU, within Europe itself on GDPR. So this is a very expensive problem, to the point where cyber insurance has now become very popular, very popular. It's required to conduct business now. There's some very well-documented breaches. Citibank over a year ago, they ended up losing hundreds of millions of records of their banking clients. They came out and said, hey, it's okay. We have a cyber insurance. So our cyber insurance we have is about $400 million in cost. They say it's good. We've done the analysis. It's about $300 million, and then people paying out as the insurance companies. Bad news, because now insurance has gotten more expensive, much more expensive. And even then, people don't know how long it takes, how long they've lost the data. On average worldwide, about 280 days it takes to not only detect, but to figure out how bad the loss is. It's about a little over 200 days just to detect that loss. So people don't even know how many breaches have actually occurred and how much data is continually pulled out, because data is not static. It continues to be updated, new clients, and that information continues to get stolen.
And sorry, Lance, just on those figures, why, if that is the cost of a breach and everything that goes with it, why is it so reluctant it seems to be reluctant of businesses to invest in a robust security system, or robust data protection system? Is it they want to, they're just, it's an unknown cost, so they can't see it, and then they get an attack, and then it's a cost, and they go, why didn't somebody else say that to us?
Yeah, I'm going to back up. They do. And there's a lot of companies out there that either try to protect endpoint devices. You've maybe heard of a company called like CrowdStrike. Certainly you've heard of Norton and Symantec. They all try to go and protect what's on the left-hand side. And I'm going to give you a concept of perimeter security as I do go back to this drawing that you can see. You sit there and you put a perimeter, and you can extend it all the way out, to the end user device. And what you're doing is you're trying to guard that data. You're trying to prevent people from getting to it. And they are, and look, the businesses are trying their best to make sure that happens. But when you start looking down the lower left-hand set of bullets, you can't stop human error and insider threats. Human error is that, we didn't update a server with the newest code, or to try and prevent ability for someone to do an attack on that particular device. All they need to do is get one. Now folks are starting to watch Internet of Things. You have a printer within your network. It is a liability. When someone gets to that printer, then they drop some code, they get into another system, into a server, and they're completely broken it very quietly. These guys are getting really, really good at this. So we're just saying, look, protect the data in the open. You can put more layers of security in, and they are, Gavin, they're trying extremely hard. But I'm saying, look, they're trying, and I got to look at the circumstantial evidence. We're still losing data at a faster rate. Meaning because, that's how we're conducting business. And when you look at those big pictures that I showed before, this is why it's being centralized in these various different forms. And you go to someone like Microsoft on Azure, they have a very, very sophisticated system to try and see who the users are, to try and ensure that someone can't get to the raw data itself. But unfortunately, we go back to human error and insider threats. The Citibank one that I mentioned, unfortunately, that was an ex-AWS employee who had enough knowledge to go in, take the data, and post it. That's going to continue to happen. When you look at our system, that DBA up in the upper left-hand corner of the drawing, that database manager and DevOps. Notice one thing about this drawing. When you look at the data itself, the data paths are in blue. The management path is in gray, in black. DBAs don't get access to the data. If they did, they would need the keys to do it. So in theory, if you're able to deploy this, and in practice for Bonafeyed, you keep the keys away from the DBAs, they can't get access to the data. I'm going to tell you that some of the information about what's available to insiders is amazing. The sensitive data, about 80% of employees within a company have access to that sensitive data. That's the insider threat. What if it's all encrypted? And only those folks are supposed to see it, get it. Now with the keys, you can turn them on and turn them off. You can diversify them as well. You need multiple keys and multiple approvals to get to data. In a healthcare system, you could literally, this is a good example. Let's say you're an end customer, the service you want to provide in your health service that you say to your customer, to your patient, you have full control of who access to your data. Well, we can control the keys for that. So, you know, the customer or the patient can say, look, I want my doctor to see it. But then something happens, you need a specialist. And your doctor says, look, I need you to go see the specialist. You can literally turn on a set of keys to say, you know, for the specialist, they can have access to your health data, your PHI data for, let's say, a week. And then you can turn them back off again. That's the kind of control and granularity we have. You don't have that today. You basically have your centralized records and you open it up to your specialist in their office. Everyone there can get to it. And look, I'm not going to say the nurses and the administrators are going to, take that data, but they have access to it. The more people have access to the data, the bigger the risk is. So we have to control it where the source of the data is.
Lance, I have a quick question there. Just regarding the data, like obviously we have all these keys and a certain individual is going to have the keys in order to unlock the data. Is there a possibility that if there's certain data encrypted and the individual that had the key is no longer able to access it, what happens then?
You mean from a key that's been deleted or lost?
Yeah.
Okay. I don't know. Todd, do you want to try and answer that one? That's a fun one, by the way, because this is all about key management. It's completely transparent for us.
Yeah, so for the key lost, I don't really have an idea of a key lost, but let's say you want to delete a key. So what's an example? Well, you want some data that's never going to come back. Maybe it's somebody wants to be forgotten. You know, we'll take one of the GDPR kind of flavors. So if I'm someone in the system and I want to be forgotten, if the system deletes all of the keys associated with me, well, if that key's gone, that data is never coming back. All right. I mean, you have to try to brute force it, bring it back. It's not going to come back. Now, the nice thing about that is that by deleting the key, I've lost access to the data that's right there, but I've also lost access to all of the backed up data. Right? I don't have to go try to prune those backups, which is a big business people are trying to figure out now, right? You got to bring back the backups, restore them, delete the stuff, create the new backup. Well, there's still backup of those and they're offline, so it doesn't work. But if you delete the key, that data is never coming back. So that's the main model you have there. Now you can also decide that I want to disable the key. So I don't want to let, maybe I created a key and I gave lots of people access to it. And I just want to turn off all their access, but I want to keep my own. So in that case, we call it a disabling the key. I'm the owner of it. I created it, so I still have access to it to access my information, but nobody else does anymore. I don't have to go through one by one and take them off. But as Lance mentioned before, we have a lot of attributes on those keys. I can decide who can get to it. I can decide when it actually becomes available. Go down the path of doing, you have a promotion coming up on your website, right? And it's encrypted until that day, and then the key is available and people can see it. Or it's only going to last for 3 days. Or I say a key is only accessible 1,000 times. And I put out a coupon and the first 1,000 people get it, right? So the first 1,000 people to access it get the key, then the key dies. We give all these kind of attributes around the keys to facilitate these various types of business models. But certainly once a key is deleted for real, it's not coming back. The data is not coming back. And architecturally, we'll go down that path as well. We also don't back up the key servers. All the IT people right now are freaking out listening. So, but that's normal, right? If I have a backup of the keys and you delete a key, then I restore backup, your key is returned. Okay, so there's regulatory things around that, but that's a different discussion there. But in our model, we make sure our system doesn't go down, right? So it's replicated around the planet in different locations. So, and that's pretty straightforward. People know how to do that now. But it means that we don't keep a backup of your keys, right? If a company wants to do that, they could bring the keys down, they could stick them in a vault. You know, I proceed with caution when you do that, because now you've got your keys, right? When we have your keys, you know what's going to happen with them. If you get your own keys, you know, you've kind of pulled it out of the protected domain, and you got to keep them safe. But definitely, if you delete a key, it's gone.
Okay, yeah, because like it's just like I'm not really sure. Like if let's say for instance, if I'm working for, let's say, Citibank again, we just use them as an example, and I'm like, okay, these guys did give me a promotion. You know what? I'm leaving next week anyway. I'm just going to delete all their loads of their keys, and that is a lot of sensitive data. And yeah, best of luck.
Sure, but yeah. So I'll take your thing all the way to the end. Let's say it's the CEO who demanded to have access to everything. I always have fun with CEOs who want all the keys. Anyway, so they want all the keys, right? They're the boss. I get the keys. Don't argue with me. All right, here's all the keys. You know, live carefully. And they, on the way out the door, they want to delete it, right? But again, we have attributes on those keys where it says, if you want to delete a key, we don't just delete it right then, because you configured it to say, you know, wait a week for a confirmation, or wait for a secondary one, or, you know, mark them all as disabled. And before we delete, we require 3 of 5 people to approve it, right? With some kind of security token or whatever. So we can facilitate all those kind of situations that come up. And in some cases you want that. But it's interesting, when we go on this path, we end up on these things about all of these. I mean, they're kind of edge cases, but they're a little bit far-fetched. Whereas if we come back, what happens today? What happens today is you build a system, and most of the security in the client server systems you build is in the client. So everybody logs in, but I'm going to keep you from seeing a sensitive piece of information just by not showing you the field. I'm going to give you a different view or a different screen. That's how I do it. But the data is still in your machine. The query might have brought it back. I didn't restrict your access to it. I mean, I script what you could view. Maybe I didn't do the query, but let's say you do something to get around and you exploit the query, or you find that invisible field. We used to do that all the time in Windows apps, right? You go and you find all the invisible fields and you make them visible, and you see all kinds of neat stuff. I'm a little dated doing that, but anyway, it used to be how we did that, find all kinds of neat things. Well, here, if the data is encrypted with Bonafeyed, even if I find a way to expose that field and see it on screen, I don't have the key for it, right? Because I logged into that system and I have another set of credentials to get into the key system for Bonafeyed. And if I don't have the keys, I can see the encrypted data, but I still don't have a key to decrypt it, right? So we really moved down the path, and this didn't require anybody to rewrite their systems. They can still have their UI the way it is now. That's maybe not the optimal way from a security perspective, but even if people exploit that UI, they're only going to see encrypted data. It's a way to really add on to what people wanted to have happen, but make it real.
And I would like to add something there, Kenny. You know, something that is happening in the world today is, you know, people are getting impacted, right? Companies are having to do, you know, really radical things, radical move, just to stay up and running. And people are getting impacted, and we're seeing that where people, you know, intentionally, they grab data from the company and they walk away with it, right? And then they figure out, because in the black market, they figure that, you know, they can monetize it. So it applies to that. It applies to what's going on in the real world right now with people getting impacted, getting let go, and also with you know, big companies acquiring smaller companies, the M&As. So it applies to those as well.
For sure, for sure. And just like one other thing, and After this question, I'm gonna stop. I'll let someone else have a chance. But just from like a pricing perspective, and I understand totally about all of these keys, and there's so many of them. Like, we're going to have a lot of businesses that are in the kind of SMB, SME, that are not at the enterprise level. Are they going to be able to afford this solution?
Yeah, I think I can take that question on. It's very straightforward. So we're basically in the business of key management and offering keys as a service, and then we have the client deployment. The model is pretty straightforward. We just need to know how many clients and users that you have, and there's a nominal annual subscription fee for that. Right now, today the retail price is $25 per person per year. And then when it comes to keys, it has a step pricing designed in such a way that the more keys you use, the cheaper it gets. And it gets down into the tenths of a penny, for a key, right? So we imagine folks using millions and millions and billions of keys. For the larger corporations, it gets into the trillions. And so we've designed a system for scalability and reliability. You heard that from Todd. So the CSAs will be replicated around the world, so the performance for getting keys is negligible. There's zero impact on performance. You don't have to have control of the endpoint devices directly, within your network domain. This is the good news, right? If you want to protect the transfer information to your clients, right? That you don't want to own their machine, you don't want to deal with the software either. You can embed it into the app itself. You can operate through a web browser. They just load up a plugin for web browser, and everything works. They don't get a hit on the keys. In fact, people don't even know the keys are happening. We have something that's a transparent use case here, where there's no application or user awareness that's necessary. It just happens all in the background. We encrypt the data so it looks like data, so it operates within the entire system itself. We don't make any changes to operating systems or applications, and we automate everything for key management just relating to those users. So we want millions and trillions of keys to be used. The cost becomes, now so inexpensive that it's at one point, because through the step pricing, you get into the millions of keys. It's fractions of a penny. So we keep those costs under control.
That's perfect, because I know it's the type of security that I know from a West Tech perspective, we're trying to hit out at the SMB, SME kind of customers, and really show them that if you're not going to need pretty much anything else once you have this. And I don't really like saying that, but it's kind of, in a way, you don't. If you have your data encrypted on your database and nobody can decrypt it, it's pretty much okay, right? Because you don't need to have all this your big perimeter fence, or or even, I was speaking to a guy there last week, and I basically said to him, I was like, look, when you're going to burglar a house and one house has an alarm and the house beside it doesn't have an alarm, which one are you going to burglar? You're going to burglar the one without the alarm. And from a Bonafeyed perspective, we can say, okay, Bonafeyed is the alarm, and it's going to basically show people that, what, if you go in there, no, there's no point. Let's move to the next one.
I like your analogy, but I'm gonna put a bit of a twist on it. You've locked up your entire house, you set the alarm, and you leave the key in the front door. With Bonafeyed, you walk into the front door, and every valuable in your house is in its own separate safe, bolted to the floor. So go ahead, walk in the house. You're not going to get your valuables. That is the difference. Because if we talk about an alarm, it's a perimeter base, right? So you have a sensor, on your window. If somebody opens your window, it sets the alarm off. What happens when you break the window? No alarm goes off. Unless you have a motion sensor in your house, all you're going to do is detect that something happened. You don't know what got stolen. But if we were to put 500 safes in your house, and every safe has something valuable in it, you're going to know precisely what you have and you don't have. That's exactly what Bonafeyed does. This is why I can tell you that there's nothing on the planet like it. We have thought about this as a security system solution, not a point solution, not one that you add on. We do recommend, by the way, that whatever security systems that are deployed, there's some very nice ones out there, and from endpoint security solutions to the perimeter base. You don't want people walking in your front door, so lock the front door, right? But have those 500 safes in your house as well.
Okay, cool.
Any other questions from the group? Those were some really good ones.
Any other questions, guys?
Yeah, I have one if you don't mind. So you mentioned earlier that the kind of sophistication of threat actors and how they've upped their game. So given that you've fundamentally changed the paradigm for them, like how do you expect them to react in terms of perceived vulnerabilities with your approach?
You want to touch that one, Todd?
Sure. I think the first thing that will happen is they're going to continue with what they do today, and they're going to start getting a bunch of data. They're going to look at the data and see it all encrypted. They're going to think about it a while. They're going to do some research. They're going to go to our site, say, okay, what are you guys doing? Is this like one big key? They're going to find out that it's more than one key. They're going to find out it's a lot of keys. And they're going to look at some data. They say, okay, 800-bit key. How long does it take to brute force that? Okay. And finally, they're going to do the math. And they're going to say, okay, this is a waste of time. And they're going to go on to the next one. Because they're going to keep going until they find data that's not protected. Because getting through, I'm not trying to pan all the firewall people and Emilio's past lives and stuff, but what do you see, right? When they leak stuff out of the NSA, what was there? All the back doors to all the firewalls, okay? So that's great. They keep people off your network. Intrusion detection systems told you that you had an intruder, and data loss protection, they tell you your data just got lost, right? They tell you all the things that are happening, which is wonderful to know, but then you're always on your heels, right? You're acting after the fact. So with Bonafeyed, they get your data. I don't want them to have your data, but one of the things that happens is if they get into your network and they lock up all your machines, okay, so you bring in new computers, ransomware or whatever they have, you put new machines out, but you don't have to pay ransom anymore because the ransom is around them using the data or leaking your data. Well, then you go to your backups, right, which are also encrypted, right? So you bring them back and we're separate. So when they take your data or they erase your data, whatever, they can't hold you for ransom anymore. And as Emilio was saying, in many countries, you can't pay it anyway. You have to kind of suck it up and move on, but you don't have to worry about them leaking your data, right? That's the bigger thing. So I think that when they see that, and then they're going to talk about it on the boards, and they're going to find out, are all going to realize, okay, if you get a bunch of data and it looks like this, that means the Bonafeyed folks are there. So, just suck it up and move on to the next one, right? That it's just going to be move on. That's all it's going to be. Yeah, that's what I expect.
So we're at the
throwing the gauntlet down then.
We're at the top of the hour, and I just want to make one last mention. We're in full production now. We can do demos. We can also do early adopter deployments. We welcome those as well. We'll work with Ken and Gavin to deal with requests. We're happy to support them in a trial period for extended time to give this this technology a try in your infrastructure. Just let us know, give us a heads up, and we can start working on it now.
Yeah, most definitely, Lance. Like one of my final question, actually, just from like an implementation and maybe a support perspective, like what kind of effort does it take to implement, and from a support, is it just coding and stuff like that, or can you explain a bit around that?
Yeah, we designed this for what we call a brownfield deployment, and is in comparison to a greenfield, right? One that's already in existence. So you can have your database up and running. And I'm going to answer this pretty quickly, but in this drawing, right in the dead center, it says setup client. Basically, you set up an application from our SDK and you fire this thing off. And essentially what you do is you make a determination of what you want to encrypt in your database, and it will read the information from your database and write it back encrypted with the appropriate keys. That takes, we do this all the time now. Especially in the demos that we have for you, you'll see that we have unencrypted forms of the database, and we have the identical database that's encrypted. You can do performance comparisons and functional comparisons. We build up the database in the clear, and then we fire up the setup clients, and they go through and they encrypt it. cool part is that you can actually do this live and on the fly, because the clients, once they're set up to understand encrypted data, if the data was already in the clear, you're in production, it's already in the clear, then the clients will get that data in the clear, and the stuff that's encrypted, it'll recognize it and begin to decrypt it. And as soon as you have it fully done, then the clients, themselves have to have those keys to see the information in the clear. So we can deal with these brownfield deployments. Super straightforward. It's just hard work on the front end. It's just kind of setting up the client to read data and then write it back encrypted. That's it.
Cool.
It's not hard to deploy at all. 2 lines of code if you have a smart client, a web browser plugin, if you don't. And we have our proxy box. It's called a DSX. It's just a bump in the wire. You can literally deploy right away, not have to touch any of the clients, but all the clients have to be hooked up through the DSX box. You can get it up and running in minutes.
You shouldn't undersell the simplicity of that. If people were going, hey, we're not going to pay that. No, but no, thanks a million, Lance, and the team there for this evening, and for Kenneth to kind of putting us in contact. I'm going to leave it there for this evening. It's been really interesting I hope for everybody, and I'll post this video tomorrow, and we'll hopefully get some more questions coming off that, and I'll redirect them into your path.
Fantastic. Thanks for the time again. Thanks, everyone, and I appreciate you spending time with us tonight.
Thanks,
Thank
guys.
you.
Thank you.
Ciao.